Hello and welcome to part 4 of the Java REST Service tutorial series. In this episode, we are finally going to work on some functionality for this API. We have been using the getHttp verb for the last few episodes because it's the simplest one to use. Well, this is going to be the last episode that we will concentrate on the get verb. Today we're going to build functionality, or sometimes it's called resources instead of functionality. We're going to build a user-managed inventory of computer parts. So basically we're going to have a whole bunch of computer parts in a database, and we're going to manage how to search through it and how to see what's available through an API. As we build this search resource, I will also be introducing the response Jersey Java class, which will allow us to build custom HTTP messages. Lastly, we will be going over mandatory best practices that you will need to know about. Crosssite scripting and SQL injection are very dangerous, but they're also very easy to prevent. This is something that all developers should know about. So here is a simple database table that we're going to be using for our API resource. It's nothing fancy and it's not normalized, but for this tutorial series it will do. As you can see, there's 6 columns in here, and just going from top to bottom, we have the primary key, we have the title for the part, we have the ID code for the part, we have who makes the part, how many are available, and a description for the part. So that is really all that we're going to discuss in the introduction. So let's go ahead and get into the coding. Alright, so now that we're on the Windows desktop, let's go ahead and open up GitHub, and I'll also open up SQL Developer. So in GitHub, what we're going to do is we're going to go to our project, and what we want to do is that we already have an episode 2 and episode 3 branch, so we're just going to go ahead and create a episode 4 branch, which will mark the beginning of part 4. But I'm going to be changing all of my code in master again. Like I said before, part 4 is if you want to go to that branch and follow along as you watch the videos, then that's what you would do. And that's all I need to do in GitHub. Go ahead and close this out. So in Oracle SQL Developer, I'm just going to go ahead and make my connection to my database. Go to tables, and then go to PC parts. And as you can see, this is where I had that PowerPoint slide of all the columns. So if we go ahead and go to data, what you'll notice is that I've already pre-populated some data into this table so we can use it while we're building our API resource. I'll go ahead and minimize this, and we'll go ahead and open up Eclipse now. Select OK. And we'll go ahead and open up our package, or sorry, our project. And then we'll open up our Java resources folder and our SRC folder. So currently in all the parts that we've done, we have created a database package and our status package. So for our new functionality or our new resources, we're going to go ahead and put that in a different package. So we'll go ahead and go to new, and then we'll go to package, and then we'll say com.youtube.rest, and this time what we're going to do is we're going to name it inventory. Don't be short-sighted in terms of how you name your packages, because they're probably going to do more than one thing. So this package is going to help us manage computer parts, so it's going to help us manage inventory. So that's what I'm going to name it as. Go ahead and do that. And this is kind of a small bug with Eclipse. It appears down here, but once you actually have something that goes to the package, it'll go ahead and put it into the right folder. So we're going to go ahead and create a class, and we're just going to say v1 underscore inventory. Then we'll select finish. And once that appears, you'll notice that it actually goes into the proper place. So before we move any further, I just want to take a moment to explain that I am going to be using all REST or web technologies, which means I'm going to be returning the data from the database in JSON format. So what we're going to need to do is we're going to actually need also another package, another utility package that will return the database data into a JSON format so I can return that down to the users. So while we're at this, I'm going to go ahead and do another right click again, and I'm going to create another package. So this package com.youtube. It's not going to be REST because we're not going to be exposing this package, so it's just going to be a utilities package that I want to create. And within this utilities package, I'm just going to go ahead and go to new classes, and I'm going to say to JSON. So what this Java class is going to do is it's going to take that database cursor, and it's going to take all of the data from that cursor, and it's going to put it into JSON format for me so I can send it down to the users. We will get into the toJSON Java class when we actually need it. But let's go ahead and get into our inventory.java class so that we can actually start seeing some code. So the first thing we're going to do is we're going to need to import in all of our library files. And what I'm going to say right now is that from here on out, most likely what I'm going to do is I'm going to be copying, pasting a lot more code. This is just to shorten the episode length, and it's just not feasible to be able to write that much code in a very short period of time. So here is all of the library files, or all of the jar files that we need to import in order to make this Java class work. The next thing we're going to go ahead and do, and the best way to do this, I guess, is for you to just go to GitHub and then just copy and paste it out of GitHub, is we're going to need to define the path. So for this one, I'm going to say v1/inventory. So if the URL has v1/inventory, it's going to get routed to this Java class. Within this Java class, what we're going to do is we're going to define our first method, and we're going to use right now our same old cookie cutter method that we've been using for a while. So we have a get HTTP verb that we're using. We're going to be producing application.json. The method name, I'm going to go ahead and change that to return all PC parts. So the root of this Java class will hit this get method, and it's going to return everything in our database. So we have, well, let's start up here. So we have some basic variables defined up here. We have a try, so that's the code that's going to get executed when this method gets called. We have a catch if there's an error, and we have a finally if in case we just want to double check to make sure that that connection to the database is closed. Remember, this will always run. And then the last thing we'll do is we'll actually return the string of whatever we want from this method. So let's go ahead and add some code into the try. So generally the first thing what we're going to do from a method like this, which is returning data from the database, is we're going to go ahead and create a connection. So here's my con, which I defined up here. So that's my connection. And then we're going to use our first library import, which is up here. And we're going to make a connection to our Oracle database. And then we're going to use a prepared statement, which is basically, you can think of it as a pre-compiled store procedure if you want. And we're going to do a very, very simple SQL statement, which is select everything from the PC underscore parts table and return it to me as a cursor. So in order to do that, in order to execute that SQL, the next line will do just that. So result set, which we define inside try, and what we're going to do is this query, right? This is where we defined our query, which is what keeps our SQL, and we defined it as null up here. We're going to go ahead and say execute query. So now we have a cursor that we can do something with. Now, in the previous episodes, what we have returned is a single string, but this time we're connecting to a database, and we could have multiple things returned to us, and we don't want it just in one big blob of text or one big string. we want it organized into a JSON format so that when it goes down to the users, they can very quickly decipher what's in each row. So in order to do that, what we need to do is we need to go back to that to.json, and what we want to do is we want to send them, or send our utility, the record set, and tell it to parse it into a JSON format that we can use to return back to the users. Before we go any further, let's take a moment to explain what JSON really is. JSON stands for JavaScript Object Notation. It is a human-readable open standard for transferring data. It's basically a simplified version of a JavaScript object, and it uses key-value pairs in order to represent data. Here is the database table that we are using. If you wanted to represent one row of data from this table in JSON format, it would look something like this. So basically we have an open and closed curly brace. That would represent the start and the end of your object, your JSON object. On the left hand side of the colon, that would be where your key is, and this most likely would be your column name. On the right hand side of the colon, that's where your value is. So that's the data where that's where the data would be stored. So on the left, we have a JSON object. This would represent a row inside our database table. In this case, we have the first row. The title of it is an Intel motherboard. The product code is 1234567 It's made by Intel. We have 5 of them available, and the description says Intel motherboard. Now this is great for representing one row, but what happens when you return multiple rows from your database connection? This is where JSON array comes into play. So in order to stack multiple JSON objects together so that you can send it down to the users, we need to use JSON arrays. And it's actually very simple. The only thing that changes is that we're now adding a straight bracket. So we have an open straight bracket and a closed straight bracket in between all of our JSON objects. And we delimit between JSON objects, or we separate between JSON objects. All we use is a comma. This is what we're going to be putting into our to.json Java class. We're basically going to create JSON objects for every row, and then we're going to place them into a JSON array, and then we're going to convert it into a string and sending it down to the users. As you can see, the code for the to.json Java class is already complete. And again, the reason why I do this is just to save time. So let's go ahead and quickly go through the code for this utility. The first thing we did was that we imported in 3 library files needed to make this work. Within the to.json Java class, I have defined one method. So this is the only method that gets called to convert database records into a JSON formatted JSON array. So once this method gets called, which is called to.json array, we have to pass in a record set. And the record set would basically come from our database connection. So once this method gets called, the first thing it does is it creates a JSON array. So this JSON array basically will hold all of our database records, and it will output it to whatever method called this method. So within the try clause, what we do is the first thing we want to do is to get all of the metadata from the table. And we need this metadata for 2 things. We need to know how many columns there are for this table, and we also need to know the column names. So we go ahead and save that into a variable. We only need to do it once. Then we're going to go into our first loop. So this loop takes care of looping through each record set. So if there's 10 records, this loop will run 10 times. Within the first loop, the first thing we're going to do is we're going to count the number of columns. And the reason why we need to do this is that when we create our JSON object, and each JSON object would represent one row, we need to know how many columns are there, because we're going to have to get data out of each column. And this is where the second loop comes into play. The second loop will loop through each column in a row. So again, the first loop is for rows. The second loop is for columns. So what we're going to do is we're going to loop through each column, and then we're going to take that data from each column and put it into our JSON object. So the reason why there's a bunch of if statements in here is because each column can have many different data types. So we need to account for each data types. Things like a boolean, a float, an integer, varchar is very common, date, timestamp, numeric. So we need to account for each one of these so that when we pull data out, the code knows how to handle that data and stuff it into our JSON object. So once it loops through each column, that JSON object is now complete. That JSON object now it represents one row. So once it goes through all of the columns, we put it into our JSON array. So in essence, once the JSON object is done, we stuff it into our JSON array, and then we start over until we loop through all of the rows. Hopefully that made sense to you, but one more time to go through this. So we loop through each row, then we have to loop through each column. So we have two different types of JSON objects that we have to use. We have to use a JSON array. This is where all of the JSON objects get stuffed into. We also, between each row, create a new JSON object. And that JSON object will keep track of each row. So we stuff JSON objects into a JSON array. And this is basically all of what the code does. It's actually fairly simplistic. Really, the bulk of the code is to go through all these if statements because there are so many different types of data types a column can hold. Hopefully you understood all that. If you have any questions, you can always just leave it in the comments. And when I get a chance, I'll try to answer them. Now, if you're asking yourself, is there an easy way to actually do this? Can I just use a library file to do the conversion for me instead of creating my own Java class to do this? And the answer is yes. There's probably multiple ones out there. I haven't really checked them out lately, but I feel that it's important to know what goes on into trying to get a record set to a JSON format and doing it yourself. It actually, in the long run, will afford you a lot of flexibility because later on you might do some things that are very particular to your application, and if you actually write your own utility to do this conversion, you can do some things inside of it that is specific to your application, and it might just save you some time in the long run. But it's also important to learn what's going on because most of these library files in essence are doing the exact same thing that this Java class is doing right now. So now that we're done explaining this Java class, let's go ahead and move back to the inventory Java class. So where we last left off is we already created a database connection, we sent up a query, and we've already executed that query. So we have data ready to be used. So let's go ahead and paste in the rest of the code. First thing we're going to do is we're going to bring in an instance of the toJSON Java class so we can use that method within toJSON. The next thing we're going to do is we're going to create a variable that's going to hold our JSON array. Once we do this, we can go ahead and use the converter, which is the instance of our toJSON, and we're going to call that method, and then we're going to put in the record set that we have up here. This will return to us our JSON array. So this is actually all of the data in JSON array format. Once we've done this, we can go ahead and close our connection to the database because we have all of the data now in this JSON variable. From here, we go ahead and we just string that JSON array into this string variable, and then finally we'll come down here and we'll return it to the user. So this is all of the code needed to go from getting a database connection, taking that connection, changing all of that data into a JSON formatted array. So let's go ahead and try this code out. So let's go ahead and highlight our WebLogic server, and then we'll go ahead and start up the WebLogic server. So once the WebLogic server is finished booting up, and we'll go in here and we can see that our project is now synchronized, we can go ahead and open up a web browser, and then we'll type in localhost, and then we can say API v1. Instead of status, we can say inventory. And there we go. We have all of the data from our table, and we have outputted it out to our screen. Now what you can do is you can copy all of this, and then if you go out to google.com and you just type JSON lint, you can go to this web page, you can paste in all that data, and you can hit validate, and it will tell us, yes, we actually have valid JSON formatted data. And what you'll notice is that this is all of the rows that's in my table right now. So we now have verified that this method does work. At this point, what I'm going to do is I'm going to go ahead and minimize this and also minimize this, and I'll open up GitHub because I want to go ahead and do a commit here because we're going to go ahead and start improving upon this method. So I'll go ahead and go in here. So I'm going to go ahead and save that. And I'm not going to push that up to the server just yet. So I'll just go ahead and minimize that. And then I can go back to my Eclipse. So what we're going to talk about next is how we define our methods. So before, we have always used string. So we're always returning a string. And what's happening in the background is that we might return a string from this method, but after it exits this method, what Jersey is doing is it's building a response, which means it's building an HTTP response, and it's taking our string and adding it to that response. We're not actually controlling any of that. So in order to build a better method in which we can control everything, we don't want to return a string or any variable type. Instead, what we would want to return is we would want to return a response. And what that is telling Jersey is that we're going to build our own custom HTTP response back down to the user or back down to the client. So in order to do this, first thing we're going to do is we're going to change this to a response. We've already done that. The next thing we're going to do is we actually need to have a way, or to have the ability to build a response. So in order to do this, we're going to go ahead and add another variable type. It's going to be response, and then the name of this one, we're just going to name it RB, and we'll set it to null. And then the next thing what we're going to do is we're actually going to go ahead and build this response, which is fairly simplistic to do. So what we're going to do is at the end of our code, we're going to say rb.ok, and the return string here, we're actually going to go ahead and add it to it, and then we're going to say build. So what this does is that we're going to take the response, which is our HTTP, what we're going to create, we're going to add to the body of it our string, and then we're going to go ahead and build it. So we're actually going to compile it together. And then lastly, what we need to do is we obviously are going to return a response rather than return a string. So that's all of the changes we need in order to make this into a method that will actually create its own HTTP response. So you don't really see the benefits of it for this one because the method is so simple. But in the next method that we are going to build, you're going to see the benefits of why we would want to do this for all of our methods that are actually open, that are actually resources that clients can hit. So let's go ahead and save this, and then we will republish this out. Go back to the server, it says synchronized, and what we're going to do now is we're going to go ahead and open up our web browser again. We'll go ahead and copy this and we'll close it, and then we'll open up a new one, and then we'll copy that URL back in, and the same thing comes down because we actually haven't changed what comes down from the API. We just want to ensure that the code that we have changed doesn't break anything, and it obviously hasn't. So this is working and it's good. So let's go ahead and go back to GitHub, and let's see, can I save another commit without having to go up? Yes. And then we'll go ahead and do that commit. And I'll minimize this and I'll minimize that. So before moving on to the next method, let's talk really quickly about cross-site scripting. And it's something that's really important. And luckily for us, the newest version, if you're using the newest version of Jersey, it already takes care of this for us. But we should talk about it at least before we move on. So what happens with cross-site scripting is that, this is an example, there are many ways to do this, is that a hacker would say get into your database. And instead of bringing down your database, which is very obvious and it's not very profitable for them, what they'll do is they'll find a field like a description field. And they will go ahead and add something to the description field that is, it would be hard to pick up unless you're actually looking for it. So they would add, say, some scripts that would execute once it gets down to the client's browser. So I will just make something very obvious. So I will go ahead and save that, and I'll commit that. Oh, whoops, I exceeded the maximum length. So let me delete some of this. So that got saved. And what would happen is that your user would come in, use your API, and unknowingly they will actually download the script that you wouldn't want in your application or your API. So as you can see, this has actually already been taken care of for us. When we actually use the JSON.produce, it's actually encoding stuff for us. So the Jersey framework encoding definitely gets the job done. But I want to show you what you can do with an external library file that's designed specifically for encoding. So what we're going to do here is quickly just going to go back to this page, refresh so that we have this example up and running, and then I'll open up another one, copy this URL back in, and we're going to be using this second tab. So actually, we're going to go ahead and find it and download it. So what this is called is ESAPI version 1.4.4. So if you go to the OWASP, so this is Enterprise Security API, go ahead and select that. They actually have APIs, this encoding API for pretty much all of the primary languages. But we're looking for the Java EE right here. And then what we're going to do is we're going to download the 1.4.4 complete zip. So if you go ahead and download it, it's about 9.5 megs. I've already actually got it downloaded. Looks like I'm just downloading another one. So what you would see is this ESAPI 144. So if you double click in here, what you want is you want the 1.4.4 jar. And if you go into configurations, you would want the ESAPI.properties. Those two files, you're actually going to go ahead and add them into your project. So let's go ahead, and I believe I already have this saved out there. So let's see. Program files, nope. Oracle ESAPI. So I already have this saved out here. So let's go ahead. So I won't unzip it since I already have it. So what we're going to do is we're going to come into web contents. We're going to go to web.ini or INF. We'll right click, new folder, and then I want you to add a folder called classes. And in here, shouldn't have closed that folder out. We're going to come in here, we're going to go into configurations, and we're going to take the ESAPI library or properties file, and we're going to add it into the classes folder. So now it has the ESAPI here. Go ahead and go back to this. Let's go up one. And then we're going to take this ESAPI 144 jar file, and we're going to go ahead and add it into the libraries. And we're again going to copy it in. So now we have the ESAPI 144 and the ESAPI properties. For what we're using it for, we actually don't need the properties, but we're going to add it in there just to get rid of an extraneous error that we would get if we don't add this in here. And that's really all you need to do to add the enterprise security library file into your project. So let's go ahead and go to our toJSON Java class, and in here we're going to go ahead and add in that library file that we just added, the ESAPI. So we'll just go ahead, copy and paste that into our toJSON. We're also going to need a temporary variable now, because we're going to be encoding this, and we need a variable to use during conversion. So we'll just add a string variable right here, and then we're going to come down here and we're going to go to the varchar, because I know all of the strings get is basically a varchar. So I'm going to go ahead and I'm going to comment these two out, and then I will be adding new code in order to encode this. So let's spend a moment to take a look at this encoding. So basically, the first line is we're going to go ahead and get that column name, and then we're going to be changing it to a string. Instead of saving it straight to our object like we would do normally, we're just going to save it to a temporary folder. What we're going to do next is we're going to convert it back to its base state. A lot of times hackers, or just in general, some things are already encoded. What we want to do is we want to make sure everything that we're going to try to encode is at its base state. So that's what this line is actually doing. So we're going to make sure that everything is unencoded, because we want to see everything in its original state. And then finally, what we're going to do is we're going to re-encode it, and what we're going to be using is to encode to HTML, and then we will finally put it into an object. So instead of having one line of code doing something, we actually are adding it, increasing it to 4 lines of code in order to do the same thing. So if we go ahead and save that, and then we republish this, we'll come up here, and then we'll do a refresh, and you'll notice this line of code now is drastically different from our previous line of code. So let's go back to index.html, and we will take this whole thing. We'll take this whole string right here. We'll do a copy. Oops. We'll come down here. So this is what Jersey encoded for us when we first saw it. Let's take a look at what the other one did. So we will do this whole thing. Oops, wrong button. And this is what we get when we actually use, when we use the ESAPI. You'll notice that the encoding is drastically more complex, or it encodes a lot more. So let me just delete that one, because we all know that one breaks the page. If we were to save this, and then we would go to index.html, you'll notice that with the new type of encoding, we actually see the attack printed onto the screen. So we now have physical proof that we're actually being attacked. And this is something that, you know, if you go to that page and you see this, you know something's up. So this is something that while it might be embarrassing, I guess, if your users actually see this, but they'll at least alert you to the fact that something is wrong, and most likely something, your database has been poisoned and it needs to be resolved and things need to be audited. So again, the Jersey framework does encoding for us, and it does a good enough job is what I would put it at. But it's also worth using a library file that's dedicated towards security to help you do the encoding, because it's just going to outright do more in performance. And it's not really a whole bunch of lines of more code, but if your API is dealing with sensitive data like credit card information or personal information, it's well worth having, it's well worth using. This is actually a good chance to go ahead and do another commit, so I'm just going to come in here. Well, you're going to go ahead and sync that up. I was hoping to get through all of these subjects in one video, but this one's already running about 35 minutes and we still have a lot to cover. So I just decided to go ahead and just push this off to episode 5 and finish it up. So in order to finish up the get verb, we still have to talk about query parameters and SQL injection. And if I have a little time, if the video is under 30 minutes, I'll also spend a little time to talk about GitHub and how to utilize GitHub to get the most out of these videos. As always, thank you for your time, and to my subscribers, thank you for your support.